you, managing your own learning plan is very, very important. And so, again, it's for that reason of there's so much to learn. But one thing you can be certain of is that you should learn the basics. And in that list of resources I would send you, I cover this first thing I'm going to talk about, and it's the machine learning pipeline. And there's several things important in that pipeline, but rather than try to give you that talk here, when you connect with me on LinkedIn and ask for that big message that I send to people I mentor, you will get a link to that talk so you can watch it online in your own time. But it's called Learning the Machine Learning Pipeline, and basically how you can get to a point where you're automating it. And you don't have to do that in any specific language. I'm a Python person. I love Python, but I have dear friends that are good data scientists, and they use R. And you could do the same things with R. But the reason you want to learn that machine learning pipeline is it applies to many problems you could encounter as a data scientist. But if you learn those basics, you'll be well suited to tackle many problems. And in fact, when you are doing a good job at visualizing your features or your inputs before you start the modeling process, much can be explained just at that level. And so by having that emphasis on the machine learning pipeline, you are already beginning to know what you should have in your plan and what are the parts of that machine learning pipeline you need to learn to be able to do a really good job on your task. Now, that would be the first thing, learn the pipeline and then detail out the things that are in the pipeline. But then there may be times where you finished your work for the day or your studies for the day and you're learning, and you realize there's an area of passion that you don't necessarily have to learn it for your job or for what you're aiming at, but it's something you really want to know. Well, let's just say, for example, it's reinforced learning. That's a very hard area. And it would emphasize, again, there are things to get to a certain point with reinforced learning that you would need to have a knowledge of to get to a point where you were really good at reinforced learning. So you still have to have a plan even for how you go about learning reinforced learning. And that plan will, of course, include several basics that you need to know along the way. So it can be challenging sometimes to come up with a good plan. But again, as President Eisenhower said, plans are worthless, planning is indispensable. That research you do to figure out what it is you need to learn to accomplish what you want to learn, that's very important. And that plan that you come up with, the first plan you come up with, if it has the basics in it and the important basics, that will be very good. But if it doesn't have the basics, you'll soon find that to learn that important thing, you need to cover the basics. And once you have that learning plan in place, I want you guys to think of it as an ultrathon, meaning a marathon, a long running race or a long walk. I recently learned that the longest walkable road in the world starts at the southern tip of Africa and goes all the way to the most eastern tip of Russia. And I thought, oh, that would be fun to walk. Well, imagine you're taking that journey, but it's your data science journey. And you have to have a spirit of, hey, this is hard stuff. Even if I don't encounter any difficult individuals that I have to work with along the way, this is still a tough area. So you've got to take it one step at a time. Don't think you can just breeze over the basics and understanding those really well. If you understand the machine learning pipeline and you understand how to do linear regression real well and logistic regression, you are well on your way. And then what I'd like to do at this point is stop and see if there's any questions and go on from there. And you can put them in the chat window. That would be fine. So I'm not sensing any questions, and I'm wondering, would it be better if, Mandela, would it be better if I shared my screen and went through that machine learning pipeline? Or
yeah, it would be good.
Okay, good. I will try to do that. Let me pull that up. And please, guys, as I go along, it is fine to ask other questions. I hope you will feel free to do that. But I'll go pull it up. Okay. I'm going to share. Okay, guys, can you see this slide okay? Mandela, is that showing up okay?
Yes, on my side it's showing up unless someone else has a complaint. On my side it's okay.
Okay, great. I will go on from here. And again, guys, I really value your questions because to me, this session is for you. And I want to make sure I get as many questions that you have about a data science career answered as possible. So I've given this talk many times and it's resonated well with a lot of people. It's called automating supervised machine learning pipelines a little bit at a time. And warning, this talk may raise many questions. I hope it will. And I would really rather you guys ask me questions in the middle than save them for the end. So let me read this out loud, and I want y'all to think about it deeply with me. I've encountered many great mentors in many forms. One powerfully recurring principle taught by them: the greatest practitioners in any field take time to master the basics. The basics are the foundation of any great art in life. Masters literally practice the basics tens of thousands of times. I am all for the latest cool tools and techniques, but they will crumble as a house with a poor foundation if not built on good basics. Now, when I show this slide, I expect it to be overwhelming. And by the time we get to the end of this presentation, we'll show this slide again, and I think you will realize, oh, it's not that bad. But if you've ever had the experience of looking into the cockpit controls of a large airplane, it can be mesmerizing with all the dials and controls and everything. And this probably looks that way a little bit too. But let's make it a little simpler. This is really what it comes down to at the highest level. We have a pipeline. And for that pipeline, we have features which are like inputs. And those features are really samples from a larger population of data. But we want to reduce those features down to the essentials. And then sometimes we have to engineer additional features or inputs for additional needs. And then we have the labels. These are the outputs. But what we're wanting is to be able to predict future outputs. And so what do? We find a model that given a set of features will predict the outputs or labels. And so we come up with a model that will help us do that. But it still requires human oversight. For example, let's say that we had a robot. Well, that robot might do a great job early in its work, but over time, the parts in the robot wear out, and you need to take it down and do maintenance on it. And then when you bring that robot, excuse me, when you bring that robot back online, it's not going to perform the same because actually the model's changed a little bit. So what's important to do is know how to retune this pipeline, this model. And again, if you think about it right here, every time we get new data, it's just a sample from a population. Well, when you sample from a population, even if you try really hard, there's almost always going to be some amount of bias in it. And as you bring new data in, there's going to be additional bias. And so that's why it's important to have this human oversight. And once. Okay, let's go to the next slide. Now, let's just take this a little bit at a time. Here's how that previous slide would look like in a flowchart format. We've got our features as inputs. We run them into our model and we make a prediction. Now, at the beginning, at the beginning of training this model, the prediction is going to be really bad. And so we're going to get some errors, and we compare the predicted output to what the known outputs should be. And we get an error, and we pass that error into the training part of the model, and we update the model with the new trained parameters. And then we do that again. Now, there's very few problems in our machine learning world, our data science world, where we can do this in one step. There are some, but usually we're iterating until the predictions reach a best point. And it won't be perfect because even the data output itself is not perfect. It has variance. So we're just looking, if the variance is between here and here, we're looking for a model that predicts somewhere in the middle with the least amount of overall error. But one thing you really want to remember is all machine learning problems are math problems. Even if you're working with text in natural language processing, there are clever ways to turn that into big mathematical hyperspaces with numbers so that we can, again, use numbers because that's what computers use. Well, as you go through this pipeline and you're looking at your features, there's a lot of work to do. In fact, at least 80% of your work will be dealing with the features in a very smart way. And why do we care about this? Garbage in, garbage out. If you don't get your features in good shape, the model won't do good things for you. Your work will be hurt. And I should point something out. Let me go back up here real quick. When we're beginning to look at these features, we're going to find missing values, but the first thing we want to do is some histograms, basically distributions. We want to visualize the data in as many helpful ways as we can. So as we visualize that data, as we look at it carefully, we probably are going to find some missing values. Now, depending on the field you're in, depending on the type of problem you're working on, sometimes you have almost no missing values, sometimes you have a lot. But it's important to know how to deal with those. And sometimes, now imagine the data's in big tables, okay? You've got rows and columns. The rows are according to each data record, but the columns usually define the features, and then one or more of those columns can define the labels or the outputs. And sometimes you find that you're missing so much data that you've just got to delete certain rows. And sometimes you're finding that some columns are missing too much data and you might have to delete those columns. And sometimes you have to delete those pairwise. It depends on the situation. And this is something you have to make decisions on based upon your specific data set. But then there's imputation. You can actually, and you have to consider the type of problem, you can fill in those missing data with modeling too. And the way you do it depends on the type of data you're working with. If it's time series, you do it a certain way. If it's a general problem, like with continuous or categorical data, you do it another way. But you're literally, let's say here's your group of features. And this last one over here is the one you're trying to fill in data for. But many of the other rows do have that data. You're basically trying to use the rest of your features to predict the missing values for that one feature, but you're training a model using the feature values that aren't missing. And that way you can use that to fill it in. And people that practice this and do it well, they get much better models because they're working with less missing data. Okay, now that's dealing with missing values, but sometimes we just have dirty data. And what do we do in those cases? Well, one form of dirty data could be an outlier. When you're looking at that visualization of your data and you're looking at what is, the pattern of the data, there's sometimes a few points that fall outside the typical pattern, and they're very suspect. And what can be very hard about that is the best thing to do is go find out, do some research. That means getting away from your computer screens, going to talk to people, trying to figure out what could have caused that outlier. Sometimes it's okay to remove them, but you need to be very careful. Sometimes those outliers are telling an important story that needs to be dealt with. Sometimes the pattern seems strange. They're not like you expected. So I would say a lot of data cleaning data is going and doing good detective work, finding out why it's that way. Again, this overlaps with the previous thing. Sometimes we just have erroneous data. It may have been an order of magnitude off. Maybe it was manual entry and someone put the decimal place in the wrong place, or the decimal in the wrong place. Again, sometimes it's just the missing data, but sometimes those extreme values are true. They're telling that story. And sometimes you can't find the right answer. You just need to be very careful to say that you remove that outlier or that dirty data and do what you can to fix it. But still, always keep it documented. That's really important. And then a lot of our data cleansing, I would say the most of it, is just getting the data in the right format so that your machine learning algorithms can use it. And we'll talk about that a bit more here. A big part of that, getting it in the right format, is encoding the data. Now, remember how I said all machine learning problems are math problems. So if we have language as our input, we want to turn those words into numbers. Well, here are some common ways to do that. One hot encoding is when, let's say, you have colors, red, blue, green, and blue again. Well, over here, we're going to binary encode that. So one hot encoding means, oh, if it's red, we'll divide these colors into 3 columns now. And so if red occurs, we'll put a 1. If it doesn't occur, there's a 0. Same thing with blue. If blue occurs, it's a 1. If it doesn't, it's a 0. One moment. So, but why do I have this green column shaded? Well, what does it imply if red and blue are 0? it means it must be a green. So the model, if you give this information to the model, it's actually too much information. It already knows it's green by the fact that these two are 0. Now, what if you can't do that? Well, you can do ordinal encoding. So let's say it's something like this: bad, poor, okay, good, excellent. How could we encode that? Well, we can just assign a value for each of these qualifications. So 0 goes for bad, 1 goes for poor, 2 goes for okay, 3 for good, 4 for excellent. But obviously, problems can get even more complicated than this. Well, let's say you have a large group of documents. So the documents are the columns here. And let's say that this is just a marker for a word in that document. So for word 0, we can say, oh, there was 1 occurrence of that word in this document. For word 2, for word 1, I'm using coding counting, which starts at 0. For word 1, there were 2 occurrences of it. For word 2, there was 1 occurrence of it, et cetera, et cetera. And you can see sometimes words don't occur in another document. Sometimes they occur frequently, sometimes never, et cetera. Well, how can this be powerful? I actually used this principle recently to encode a large set of documents and use it to find, when I had a new document come in, find out which document that document was closest to in our existing group of documents, our existing corpus. And because I was able to use some really good toolkits in Python, for example, NumPy and SciPy and sparse matrices, I was able to do that really fast. Among 60,000 plus documents, I could find the closest matching one in under half a second. And that was very exciting to be able to do. Now, there's more complicated ways of turning an entire vocabulary for a language into numbers so that they're like vectors in a big hyperspace. But I'm not going to go over that right now. Just know that that is possible and very useful and powerful. Well, there's another way we can format and condition the features that's very helpful, and it's calling normalization. We're basically controlling the numerics when we do that. What do we mean by that? Well, let's say you're looking at things like body mass index. That involves looking at, excuse me a minute, I'm going to clear my throat. That involves looking at people's weight and height. But those are numbers that are on different scales and look very differently. And we would like to learn something from the parameters in the weights. So if we put all of the features on a level playing field, they're scaled to the same range. Now we can get a very accurate picture of which features are most important. And so what are the different types of scaling you can do? Well, you can scale between the min and the max, so that maybe your min was something like 150 and your max was something like 250. Well, now you can scale that so that the min is now at -1 and the max is at +1, but they're all still the same relative distance apart from one another. But now you can do that with all the features. You can put them all between -1 and +1. And so the different types of scaling you can do are min, max, standard, quantile, power, unit vector. I would say more than 80% of the time I'm using standard scaling, but there are times where you need to get more creative because of the nature of your data and use one of these others. But again, the real goal of this is putting all those inputs, all those features on an equal playing field. Now, the next part is to reduce our features. quite frankly, there's sometimes features that just aren't giving any value to predicting the output. And there's ways to figure that out. And we don't want features that aren't giving us value. So there's some good techniques for figuring out what those features are and getting rid of them. But there's also some other things that cause us to want to reduce the features. And one of those is co-linearity. Now, that's a fancy way of saying there's two features trying to do the same predictive job. We don't need them both. And so what are ways we can figure out which feature to keep when we have two or more features that are trying to do the same job? Let's talk about that. Again, collinearity is redundancy of individual effects, and it reduces the accuracy of our model weights because imagine a soccer team and two people are trying to play the same position. Now what happened to the other position? That team's not going to be as effective. So we want to get one feature doing each job. Now, if two features are collinear, they will look like this with respect to each other. That says they have a strong relation to one another, and we don't want that among the features. Remember that, among the features. We do want a strong correlation of each feature that we want to keep to the label or the labels, but not among the features. And so sometimes this is caused by inadequate data collection or an overdefined model. But if you leave those collinear features in there, it will cause problems in your modeling. So how do you identify the collinearity? Well, you can do it with a matrix of plots like this, where it shows each feature with respect to every other feature. And the ones that show this type of thing you worry about. The ones that show this type of thing you don't worry about. And then, so how can you deal with collinearity though? You can collect more data, improve your sampling method, and/or retain one of the collinear variables. Now again, how do we choose the best one to keep? Well, once you have the modeling going, there's methods to see numerically how they correlate to one another, and then visually, like we were just saying with those plots. But you can also use a simple model like linear or logistic regression and loop through that model and see, okay, which feature, and just using one feature at a time, which feature is going to give me the strongest correlation to the label? And there's some techniques like lasso and ridge and linear regression that can help you figure out automatically which features have the lowest weights. And if you've scaled your features and you then run it through lasso or ridge, it can really help. But you can also use metrics, how accurate your model is, and looking at that output to figure out, oh, this feature correlates with our label or labels better than the other one. And that's yet another way. But then there's this fancy thing called PCA, Principal Component Analysis. If you guys have studied it, it's a lot like eigenvalues and eigenvectors. And you're basically, PCA can tell you which one is the strongest, and then you can use that strongest feature and take away the other ones. So a little more explanation about correlation in case you're not familiar. This would be a perfect positive correlation and a perfect negative correlation. And then as we have some variance along those paths, you can see that we get, this is still high positive correlation, but not perfect. This is low correlation. This is no correlation. And now we switch to a negative again. And again, if you find multiple ones that are correlated, you want to retain the strongest feature by those methods we've been describing. Oh, let me make sure we covered everything. By the way, a negative correlation is still a strong correlation. It just means we're looking for things, when we're at one or very close to one, that's perfect or near perfect correlation. Just because it's a negative number doesn't mean it's bad. And the most common ways to look for correlation strength is Pearson's or Spearman's. They're both very strong. Okay. Now, I want to emphasize this some more. Some models are used in production, but some models are used for clarity. And I'm a big fan of linear and logistic regression, but that doesn't mean I'm going to use it in a production environment. It means I'm using it as I'm exploring the process. As I like to use it to help me figure out what features are most important. And so you can run through the model, those kind of models, again, with Lasso and Ridge. This is, I think I talked too soon. I'm saying this is saying the same things, basically, that I was saying in the previous slide. I just spoke too quickly. But the point being is we can use a mixture of methods to figure out what features we want to keep and which ones we want to get rid of. And again, the goal is to get the simplest model possible that does a good job for us. Okay, now let's say we've got it down to the smallest set of features, but we still have some problems. Well, what might those problems look like? Imagine you're trying to do this, plot a straight line through curved data. Well, in this case, and I'm using a very, very simple example here. Let's say your features are X, your inputs, and your outputs, your labels are Y, and there's no engineered features. Now, when we try to find the best slope to multiply X by, or the best model parameters, basically, we find that we're just doing the best job we can to put a straight line through there. But if we add an engineered feature, example of an engineered feature would be X squared. By the way, this is super simple. If we had our features were X, Y, and Z, we might be looking at a lot of combinations of engineered features that had different polynomial levels. It depends on your modeling needs, but we actually engineer features in an attempt to fit the data better. And in fact, having X squared here worked perfectly. And in fact, if we looked even deeper at this, you'd find that the model parameter for this was strong, and the model parameter for this one was essentially 0. So having an engineered feature is very important. But you can use polynomials, and then if you're looking at a lot of engineered features, you may have to reduce those too, because you might be adding in a lot of engineered features and find that, okay, now I've got to find the best set of those, and that's what we do. But if you've heard of deep learning, I'm sure you guys have, and deep neural networks, well, what's great about those is that when you train them, they're actually figuring out their own feature engineering, and that's one of the reasons they're really attractive and powerful. But to train a deep neural network, you have to have massive amounts of data. So I would contend that reduction still helps. So if you find that a neural network is going to do the job for you, or you're going to need a neural network, it still pays to reduce out the features you won't need, because now you're reducing the dimensionality of your problem and the ease of solving it. And so it's important to still do as much reduction as possible if you're looking at deep neural networks. And then those features that you couldn't find because maybe they were very strange, the deep neural networks can then likely deal with that. But even then, you'll have to change the architecture of your neural network to find those features. And so it's still an iterative process. Okay. That's a lot of work. And this is the hard work that data scientists usually do to get to the modeling stage. Now, sometimes it's very simple. The data is well behaved, it's easy to scale it, it's easy to deal with missing values and dirty values, etc. But if you are if you are cognizant, if you are aware of all these things that you should consider, it will make your work much more fruitful. And I see a question over here. Okay. I'm going to call you Junior, that it's Muchira. You can unmute if you want, and we can discuss this a little more if you want. But would you like me to go back to that slide on correlation? You can answer in the chat or going off mute and letting me know. Okay, let's go back to it. I'm going to go up. Okay, let's say on this axis you have your input. Let's just say we're dealing with simple data. It's just one input and one output. If there's strong correlation between, in other words, if a given input is going to result in a given output, and it's a strong positive correlation, it will look like this. All your data points will fall right on the function of a line, or a function of x squared. Or in other words, you'll be able to model it. You'll see a very smooth line. As it gets a little less perfect, this could just be measurement error. It could be something else. But now when we try to place a model or a line through this, curved or straight, yeah, it's going to be a high positive correlation, but there's going to be some distance between the predicted value and the actual value. And so there's still a strong correlation. For this input, we get this output, but there might be a little bit of error now, Machira. And so as you see it looking more like this, it's a low correlation. And when you see it looking like this, there's no correlation between that feature and that label. And that's an indication that, well, we need to go look for other features. Machira, is this helping? Go ahead and answer in the chat. Oh, good. Okay, good. And then I'm going to go on, but I'm glad you asked that in case others weren't familiar with it. Correlation, by the way, when you're Machira and everyone else, when you hear a new term and you're fuzzy on what it means, I find it's really helpful to go try to learn it from at least 3 different references. And even if you understand it the first time, I would still go to 3 or more references to help you understand it more deeply. So it can be very valuable to go study more from multiple sources, because it helps you understand it overall better. Okay, now the labels. I want to talk briefly on this. Sometimes the labels need to be cleaned, and if you're missing labels, they obviously can't be used in training, but sometimes it helps to engineer the labels. For example, if you had the square values of the labels, it might make the whole upstream process easier. This is where it's important to remain open, explore, and be creative, be inquisitive. It's rare that you will engineer a label, but sometimes it simplifies the whole model to do so. Okay, so that now, once we've got clean features and clean labels, it's time to do the modeling. And we've got to make sure that model's doing the job correctly. In machine learning, we have 2 big branches, supervised and unsupervised learning, and there's actually also semi-supervised learning. It's just not shown here for simplicity. But in supervised learning, you can have classification or regression. Classification is, of course, just something like groupings. But regression is when it's a continuous variable. And then example of unsupervised learning is clustering. And for each of these types of machine learning, there are different types of models that can be used. Now, is there a way to know ahead of time which type of model is going to do the best job? Unfortunately not. And the reason that is because excuse me, I got distracted. Remember at the beginning, we talked about we're almost always working with samples of data. And when we're sampling data, even when we do our best job possible, we can run into problems with bias. And some models deal with certain forms of bias better than others. So it's really important to have an ability to set up your code. We do this machine learning pipeline in code, and it's important to write your code in a way that you can easily try different models. But when we go to train each of those models, it's important to randomize your data if you can, if it's not time series data. If it's time series data, obviously you can't do that. But then we're going to divide our data up into train and test. But we don't want to just do that one set of train and test. We're going to do cross-fold validation, and I'll talk about that on the next slide. But as we're looking at the model performance, we want to be careful to make sure the model generalizes well. And I'll show an example of that. So we're working on the current samples, but we also need the model to work good on future samples. That's what we mean by the generalization. And then it needs to be able to improve on growing data. And then sometimes we need to change the model, and we need to have methods that help us become aware of that. And this fancy word parsimony, that just means having the simplest model that will do the job. Why do we want the simplest model? Because it's easier to understand, it's easier to train, it's easier to run it. So if we need a slightly more complicated model because it does the job better, we want that. We're just saying, don't let the model be too complicated. And this is yet another motivation for automating all this. But how do we choose the best model? Well, let's first talk about how we do that k-fold cross-validation. Now, the k is just a variable. It's saying how many variables do we want, how many folds do we want? So in the first iteration, we use this group of data as the test data and this group as the training data. And then we look at the metrics. How good is that model doing? But now we want to do all these other iterations and test across all these folds. Which type of model generalized the best? Which one had the most constant accuracy? We're making all these judgment calls to make sure we're getting the model that will do the best job into the near future. And finally, just like that robot, because this has become like a robot, we need human oversight. So human, even if you get all this automated or you get a model in production, you need to monitor it to see, wow, could another model have predicted this better? Are there some new dirty data problems? In other words, there's an opportunity to revisit the whole pipeline to see if you can improve things. So just like any machine that's running, humans are making sure things aren't going bad and that they take the machine down and do maintenance on it. So that's another important thing to consider. Now that we've gone through the whole thing, I'm hoping this doesn't look too overwhelming. This is just bringing everything back into the big picture. And I thank you. And I think it'd be good to stop here and see what kind of questions do you guys have for me? I apologize, I don't know much about your group. Is there ways I can help you about career advice or about a specific area you're struggling in and how you can get help? I'm here for you. Let me know what I can share with you guys. And we can go back over certain parts of this presentation if you want also. Mandela, Did we, are we
Yes.
going a good path here?
Yeah, I guess, unless someone has a question. Yeah, maybe you can try and go slowly. Yeah, like yeah, like take it at a slower pace.
Yeah, I hope I was not talking too fast. I'm definitely doing, okay, can you kindly share the PowerPoint? In that message, Alan, um, that I would send out to you if you connect with me on LinkedIn, there is a presentation, a recorded version of this presentation where I present with two other people. And I think that will help. I can share these also with you if you connect with me on LinkedIn and ask me for that. Okay, Alan? And then Cyrus. Okay, great, Alan. Thank you. Cyrus, while iterating, Cyrus asked, while iterating, for test data and training data, does the rest of the data become training data? Okay, so imagine this is all your data. My fist represents the test data, and my hand represents the training data. During model training, you're using this as the training data, and then you use this as the test data, but you're only using the labels here. Excuse me, wrong. You're only using the features here, and then you're checking those outputs against the labels, and you're seeing how big an error there is, and that helps you understand the accuracy of your model. Now, again, it's important to note that just because you have a prediction and it has some error, that doesn't mean it's bad. You can have a highly accurate model that's very bad at prediction because it overfitted the data. And that, when I was talking about generalizing and parsimony, we're trying to make sure we don't overfit the data. Cyrus, did that help? Okay, great, great. Now I'm going back, Lucia. In clustering, how would we compare k-means and random forest? Oh, that's a great question. Again, it comes down to choosing model metrics and also looking at what the model output is and determining which one's most accurate, but also this is why the k-folds is important. You want to make sure it's generalizing across all those folds. For example, you don't pick the model that had the most accuracy on one fold. You pick the model that had good level accuracy across all the folds and did that better than any of the other models. And I hope that helped. Let me know if it did or didn't. Now I'm going to the next question, but I'll still look for that feedback. Okay, good. Thank you. How can I run a model with two predictor variables? Okay, meaning, I think you mean to say, Alan, there's two labels, not just one label, or there's more than two labels. Is that correct, Alan?
Okay, for instance, let's say I want to run a model whereby, let's say, for example, I'm working in a sales department and I need to know about the prices and also at the same time about the inflation rate. So if I predict for a particular time, it will give me like the price is 20 when the inflation is 2. Yeah.
Yes. So the modeling process works when you follow the methods, especially if you use the Python or R libraries for fitting the model, it will handle multiple outputs. You just need to make sure you have the training data that will enable it to get there. Does that make sense?
Oh, yeah.
Okay. And guys, I want to encourage you. I know you guys are smart, but you may be new to this. Please don't be be afraid to say I'm still confused. I'm not saying you were, but just I really want to make sure we're doing our best to answer questions. I know this stuff can be hard, but basically, you're probably going to be using a module in Python or R, and you're going to be doing a training method. And if you have good data, it can train to predict multiple outputs if you have adequate data too, once you've been through the pipeline. Okay, this cross-validation results in a better model since it has to train and test multiple times in comparison to just training once. What cross-validation does is help you measure the performance of the model and hyperparameters for that model that you're choosing to see if it will do the best job across all those folds. So it's not the cross-validation that's doing it for you. It's your choosing of performance that's helping you find the model that will do the best across all those folds. I hope that helped. Let me know if it doesn't, electrical. Okay. And then Ian, sir, how can I reach out to you in case I have a question in the future? LinkedIn. And by the way, I'm also, when you guys connect with me on LinkedIn, let me know you are in this session. I will invite you to our integrated machine learning and AI Slack channel, where not just me, but many other people can help you answer questions. And then you will also get invites to our Saturday morning integrated mentoring sessions, where I mentor people every Saturday morning, but with the help of other people that care about you guys just as much as I do. And we love that time. We're like a family. So we know there's many of you out there that need help, and we're eager to help, but we have a real spirit of making sure we're helping one another. Just want y'all to know that. And so Ian, I hope that helps. Again, when you connect with me on LinkedIn, also give me your Gmail address. That way I can go in ahead and expedite that process. And then also on LinkedIn, I'll reply with that long message that has all those resources. Okay, how deep is deep enough to dig into ML concepts since some run so deep? Electrical, excellent question. And that's why having that personalized learning plan is so important, because most of the work out there where you would go and get a data analytics or a data science role can still be done with very basic machine learning. Don't rush off to try to learn deep learning right away. In fact, as you look at neural networks, you realize that they are built on the foundation of linear and logistic regression. And then to understand how they're trained and how they function, if you understand linear algebra and good differentiation in calculus, like derivatives and the derivatives with the chain rule, you understand those things, now you're well poised to start getting into deep learning. What I want to strongly encourage all of you to do is, again, treat it like a long walk, a lifelong walk, where you're going to have to stop and rest. You're going to have to take mental breaks. You got to keep rested. You got to keep your brain fresh. You got to stay healthy. A healthy body supports a strong mind. You've got to just be try to be a well-balanced person. I think a balanced life is kind of a myth, but the spirit of it is just do your best to try to keep going. Be gentle with yourself, patient with yourself. And what you'll find is over time, you gain a better and better skill at refining your learning plan, figuring out, oh, okay, I wanted to learn that, but now I realize I have to learn these 3 other things before I learn that. And that's okay. That's great. It's a beautiful journey. I just will warn y'all, if you don't like math, and you don't like coding, and you don't like continual learning, you're in the wrong field. But if you really like all this stuff and you love learning it and you love being able to use it, just be patient with yourself. Sometimes it just takes the right explanation to get it, if you know what I mean. Okay. Next question. And please, those of you that asked in the comments and I gave an answer, please give me feedback if that helped. I appreciate those of you that did. Okay. I know that you guys are in East Africa, but how many countries are represented here? Oh, thanks, Electrical. If you could type your country names in the chat, I would love that. I love knowing this, what parts of the world I'm speaking to. Kenya. Ah, awesome. Very good. So I'm curious, is Harrison out there? Oh, Uganda, excellent. So Harrison, if you guys know him, I'm pretty sure he works with Timothy, excellent. 254 in the building. Cool. But oh, Nigeria, excellent. Must be if the Nigerian. I'm hoping you know John Kamara, who we're trying to help and work with. 5A, okay. Well, great. Thanks for sharing that, guys. That's really good to know. Tanzania. I have a dear friend that lives in Tanzania that I try to keep in touch with. He's a Catholic priest, by the way. Kenya, excellent. Okay, good. All right. Are there some additional questions? Anything? By the way, I'm in the United States. I live in Eagle, Idaho, which is right next to Boise, Idaho. Not a heavily populated area, but not the most sparsely populated area of the U.S. either. Not too far from the West Coast. Okay, any other questions? To data science newbies, yes. That again, I'm going to try to pronounce your name right. Kazungu. Please connect with me on LinkedIn, and I'm going to start just giving you as much advice as I can, maybe more than you want. Okay, understood, Cyrus. Thank you. Do you know, Cyrus, do you know John Kamara? And his group over there in Nigeria? Okay. Well, when you connect with me on LinkedIn, I'll make sure in a message, I'll give you John's name, okay? All right, good. Are there any additional questions? By the way, I'm most eager to get you all connected. Oh, I work for Underwriters Laboratories. Excellent. Thank you, Joseph, for sending me a connection request. I hope all of you will. Underwriters Laboratories was founded at the beginning, near the beginning of the electrical age. And, oh yeah, we give you all my LinkedIn handle. And I'll go ahead and take this presentation off screen. I'll stop sharing, in other words. And then let me get my LinkedIn profile for y'all so it's easier to connect. I should have thought of that. It's actually pretty simple. And it's in the chat now. There you go. So Underwriters Laboratory, and it has it's an old company with a rich history, but I work for their business called Prospector, and it's the largest and most accurate database in the world for plastics, paints, coatings, personal care, and cosmetics. And it's a real help to companies that need to choose the right chemicals, those types of materials or chemicals for their developments. And Electrical, I'd love if you shared your personal experience on how you remain focused on your data science journey and the setbacks you might have encountered. I'd be very happy to share that. So I was born and raised in Dallas, Texas, and I'm 59. I was born in 61, and all my schooling is in Texas, not by choice just by opportunity and because I was born there. Good schools there though. And I went to a large Dallas high school, and I was senior class president there. I wasn't always a great student, but I became more and more focused, and I made really good grades in biology and not so great grades in physics. So what did I choose? Mechanical engineering. Makes sense, right? And then I went off and studied mechanical engineering at the University of Texas in Austin, Texas. And then from there, I went and worked with the Naval Nuclear Program, our nation's Naval Nuclear Program, and learned how to operate and do maintenance on naval nuclear powered plants. So for ships and submarines. And then I was supposed to go back to the other side of the country in Pittsburgh. By the way, that was working in Idaho at the prototypes back then. That's not even open anymore. But then by the way, there was no data science back at the beginning of my career. I fell in love with mechanical engineering and doing predictive modeling for prototypes. So, but at the same time, was I doing data science? Yes, I was learning least squares regression as early as my freshman year in undergrad in physics lab. We just didn't call it, when we were doing empirical modeling, data-based modeling, we weren't calling it data science back then. To us, it was just either empirical modeling or first principles modeling with physics. But while I was working with the Naval Nuclear Program, our mother company recruited me to work on a new submarine design, and but the manager in charge of the people that had my qualifications, where I worked with the Navy, didn't want to let me go. So I was frustrated. I just went back to graduate school because I wanted to become a professor. And so I went to the rival school, Texas A&M University in College Station, Texas. It's about an hour and a half drive or so from where my first school. And again, I was in Idaho, so I moved back from Idaho to Texas and did all my graduate work at Texas A&M University. And I was beginning to learn data science even then, more like neural networks and expert systems, but we still didn't call it that. And I did my master's on robotics modeling, and I did my PhD on design and modeling of hybrid electric vehicle power plants. And from there, I moved back to Idaho and became worked in industry for a while. And then over time, someone helped me realize, Thom, you're really a data scientist and an engineer, but data science is really taking off. I would advise that you focus your career there. And that's how that happened. I hope that helped. Can someone be good in more than, I think you mean, one field? I mean, can I be a mobile app developer and still take data science, or would that be work overload? So Joseph, I'm a learnaholic, and I really appreciate, okay, great, electrical things. Joseph, I am a learnaholic, and this is a very important question to ask. I would focus on doing one at a time, but that doesn't mean you can't create your own field of expertise where you're doing the app development, mobile app development with data science. So you might want to pick one or the other and then add the other once you know you're being successful in that first one. I think it could be great, but I've learned the hard way. Seek to master one thing at a time. That has hurt me more than anything, getting too excited, trying to learn too many things at once and not following through with that one thing I chose. But it's not to say that you can't do both at the same time. I would just be very careful to not add to those two things. You start diluting your energy and your study power. Okay, good, Joseph. Great. Oh, thank you, David. Thank you. It's I've learned. I just want to be honest with y'all. I've learned a lot of things the hard way, and a lot of why I give these talks is to help people avoid my hard lessons. Okay, so I don't mind telling y'all what stupid things I did to help you guys avoid the same. By the way, there's a book I really like. The one thing, and then Gary Keller. I had to read this book many times carefully. Again, I was a learnaholic, a doaholic too, meaning trying to do too many things. And reading that book really helped me. I think I read it 5 times before I felt like, okay, now I got to make sure I live this. And I'm appreciating these questions. I hope they really are helping a lot. Anyone else? Okay, some of us are overwhelmed by a lot of resources on data science, on the internet. How should we choose the right resource? That's a very good question. Not that all your questions are good, I really resonate with the importance. This is an important question, is what I should say. I think it's good to look at many resources. I think it's good to learn things from multiple resources, but don't feel like you've missed out because you later find out there was this other great resource. Once let's say you've realized based on your personalized learning plan that you need to go get good at this one little thing. Now, I would strongly advise find resources that you like, but try to learn it from one main one and have some other ones that help you when you get stuck. Because sometimes just reading about the same thing you're trying to learn from multiple resources often helps. You guys probably have heard of transformers like GPT-3, GPT-2, BERT. Well, I'm learning those. And there's a talk I give called Integrating Brilliance, and I'm starting to incorporate what I've learned about how to learn and grow faster and better and healthier in my knowledge, in my skill set. And I'm just a student of this stuff. I'm not trying to say I'm an expert, but trying to share it with the community like an open source model for how to learn better. And one of the things we're seeing is, I'll just share from my personal journey. I had to actually use that a lot recently. It wasn't just the one advising, I was the one using heavily to say, okay, I'm new to this, I've got to explore broadly right now. I've got to look at multiple references and figure this out. And then as questions got answered and more specific questions occurred to me, it became easier to fill in the blanks, to learn more of it. But the real big help was one night I was so burned out studying technical papers on transformers, because that's really not a good way to learn something new. There's not until recently there wasn't a book on transformers. And so in desperation, I laid on the couch and I started watching YouTube videos that described these papers I was trying to understand. And the people that made the YouTube videos have done such a great job. It really helped fill in the blanks quickly. But if I hadn't decided, okay, I need to explore my resources more broadly, I wouldn't have thought to go look at that YouTube video. So again, I hope this is helping Kazungu. Kazungu. I hope I'm saying that well. At the beginning, you study more broadly. As you start to learn more and more, you can study more specifically. But I still find it's really valuable to find someone you can run things by. By the way, when I was in grad school, we were working on such cutting edge stuff. We didn't really have anyone to ask, so we would go over to each other and explain what we were struggling with. Just the effort of trying to explain our current problem and what we were struggling with usually gave us some new insights. So exploring broadly, learning to explain it back. If you can get a mentor, that's great. But a lot of mentoring can be done just by reading those vast amount of resources. So back to your question though, a lot of resources. How should you choose the right resource? Frankly, just choose the one where you think you like the way that instructor explains things, and then keep using that instructor because you find that you understand them better. But that doesn't mean you can't go read another blog post or watch another YouTube video or get another course or a free course or whatever. Just keep doing that. And by the way, my team and I are working on developing a course that goes into the details of this pipeline. And we have a deal lined up with a publisher to publish the course that we're developing. So if you guys stay in touch with me on LinkedIn and you're following my post, you'll be the first to learn about that stuff, especially if you join our Slack work group. That would be great to have y'all in that. Okay, what's the importance of blog? Okay. There's a message I send out. Oh, sorry. I'll repeat what's the importance of blogging in data science? I'm going to go get, whoa. Okay, I'm going to go get that right now. There's some advice I want to put in the chat window. Oh, shoot. I keep this handy and I'm looking in the wrong place for it. Yeah. I'm going to just read this for y'all. Sorry for reading it, but here's how you grow toward getting the best role possible over time. You want to be noticed by the community, in my opinion. The best way to get noticed, how do you do that? Keep making your work visible to the greater community in helpful ways. Make sure people can find great things about your work and knowledge when they search on your name. So how do you do that? Share posts and such on what you are learning and on what you think would help people in the community. I think it's great to show what you know and what you are learning also. Keep a personal, private record for those things that have a short half-life, such as LinkedIn posts, and get them onto something more permanent like blog posts or a personal portfolio website or GitHub on all of them. Then when you apply, you'll get noticed more, or people might even come knocking on your door. And I hope that helped. Obviously I was reading that, so I'm going to just paste that in here. But when I send you that big message that I send to everyone that asks me for help, this is one of the things that's in that big message. And again, this is something that you get better at it with practice. And I'm going to tell you a story. There's a young woman in India, her name's Tina Mary. When I present that machine learning pipeline post, in fact, y'all should connect with her on LinkedIn. You can tell her I sent you. Tina Mary. I put that as my last entry on our chat. I invited her to join my group, the author group for the blog posts, and because I saw her posting on LinkedIn. And then she learned a lot more from me when she did her first blog post. And then because of her hard work, I invited her to teach that machine learning pipeline presentation that I just gave you guys. Well, then because of that exposure, her LinkedIn posting, her blog posts, her speaking with me, she also got invited to speak on her own. And then an employer noticed her and invited her to apply for a position. Now she's working as an intern in that position that will likely turn into a full-time position. So when you ask, what is the importance of blogging in data science? It's not so much the blogging, it's getting that vast exposure. Now, the other guy that would share this talk with me, Owen, he has a phenomenally good website that people can visit to learn more about him. And by the way, I need to have one of those, and I keep trying to get around to it, and I haven't, but I'm going to give you a link to Lewis's page. Actually, let's start out. I'm just going to give you his LinkedIn handle too. But let's see if I can find his website for y'all while we're talking. Let's see. He just has it hosted on GitHub, actually, his website. So I'm going to go check that for you to make sure it works before I send it to you. Yep. So this is incredible. You guys will love this. And you don't have to do anything quite as fancy as Lewis's page here. But it's not just the blogging. It's just, you're basically creating a portfolio online so that when people search your name, they can find your work. They can find your portfolio. And then on your resume and on your LinkedIn profile, you want to direct people to these locations. I hope this is helping, guys. Also, a good source, and you're going to get this when you when I send you that first message, you'll be directed to my blog, which I share with others now. But I'm just going to send that to you right now in the chat also. Okay, good, Atieno, I think is how I'd pronounce it. And I'm glad it's helping a lot. Good. Okay, other questions? Check the time. Yeah, I'm scheduled till for another 30. Okay, good. Yeah, I don't know if you're talking about my blog or Lewis's website, but they're all good, I think. And I'm glad it's helping a lot, guys. I do think we're having some people fall off, but I'll stick around till the end if you still have questions. Excellent. Thank you, Stephen. I see a hand raised. Going ahead. Stephen. Or maybe that was just a high five. I don't know. Yeah, Stephen, going ahead if you want.
Okay, let me ask about the blogging aspect. Do you need to be just casually in terms of making it fancy, or are you supposed to be using the technical aspect?
So if you look at the posts on my blog, there was a big turn from doing technical posts to doing posts that were more mentoring oriented. But I'm very eager to get back to the technical ones too. Hence the course and the textbook and the class that my friend and I are developing with our integrated family. But I think it's important just to be real and authentic. Like, Stephen, it's a spirit of, I'm on my data science journey. And by the way, I just learned this and I wanted to do a LinkedIn post on it. You don't have to say it exactly that way. I just mean, have a spirit. Like Tina was literally writing posts on what she was learning in grad school, and big name people were loving what she wrote because she just tried to be really clear, you know, very, very high level summary of the important aspects of the things she was learning. And even big names in data science and data analytics would recognize her name and say how good her posts were. So it started to really flourish, but it was just, Tina was just very steady at trying to give back to the community in good ways. My dear friend Greg Coquillo, who's Haitian, he is now a U.S. citizen. He was able to come to the States because of an earthquake situation in Haiti. And he was just last year's top voice in data science. And he's not a data scientist, but he loves data science because he sees its power. And now he's learning data science from me and others. But to me, he's still a top voice, even though he's not officially, I would say he is a data scientist now. He's just more one in training, but his posts are super helpful to the data science community. So don't think you can't write a really helpful post just because you're not, a top level Google researcher, data scientist. No, have a spirit of, hey, how can I help? What have I not seen posted about that I'm learning about that I think people would really value? The other day, I was surprised. I did a post just to help out a company that created a web scraping tool. And so I went and watched their 5-minute promo video because they reached out to me on LinkedIn asking if I'd be interested. And I realized, well, I don't need it myself, but I think the community should know about this tool. So I just wrote a simple post on it with a link to the video and, how they could get in contact with the company. And that post went really big. I was very surprised. And so if you come across a new Python module that's not well known, but it really helps you in your work, you can post on that. There's a lot of things, but the main thing, Lewis would tell you this if he were here, Lewis Owen. It's not the best data scientists that get jobs and opportunities. It's the most visible ones. You're not trying to be visible just for the sake of being visible. You're trying to be visible in a way that you're showing you're learning and you want to help. But also, what I'm really trying to emphasize, stay involved in the community and figure out where are there holes in the community? Where does the community need help? And how can I help that? But also be very open to how can I be helped by the community? And then take time to say, boy, I went and took this guy's class that was advertising on LinkedIn, and it was so helpful, and I just want to let y'all know it really helped me. Well, that builds connections too. Make sure you tag those people too. It's a very good thing to do. Oh, cloud computing in data science. All right, this kind of gets into some good toolkit questions. I'm a big fan of notebooks, so I like to use Google Colab. Of course, they're very much like Jupyter notebooks. There's other forms of notebooks out there, but I like Google Colab. But I'm always stressing to people, make sure you know how to do your code development in an integrated development environment too, an IDE like Sublime or VS Code or Atom or PyCharm, you name it. One of those tools, make sure you can write Python in there. Get good with virtual environments and creating new virtual environments and doing pip installs to those new virtual environments. You want to be good by being good in the IDE and knowing how to do your own virtual environments. You're getting good at knowing how to support a production environment. And let's see. So to the cloud computing question, if you're doing a good job on that kind of stuff, cloud computing is important. Many production level deployments use cloud services now. Don't feel like you've got to rush off and learn that stuff before the basics. If you are good in your IDE and good with virtual environments and pip installs and managing that environment, knowing how to freeze it into a requirements file, all of that, you're preparing yourself to be good in cloud computing too. But don't feel like you've got to rush off to learn all of them. When you feel like you're doing a good job on the basics and you want to try to do cloud computing, then you can go focus on that. I personally don't like employers putting a big emphasis on knowing cloud computing because it's basically like just learning a new environment. something that if you've done really good at basic machine learning, you can learn cloud computing. I hope that helped. By the way, some cloud computing platforms have their own data science learning track too. And so if you can combine learning the basics with cloud computing, but also make sure you can do it outside the cloud computing environment, I think that's the best of both worlds. But I wouldn't stress over learning the cloud computing until you're good with just the basic machine learning stuff. More questions? I'm just checking over here. Okay, I do have a bunch of new connection requests, so I'm hoping most of those are from you guys. And then do give me an initial message that I was in the, let me make sure I call this thing, the Data Science Toolkit session. We'll just call it from Kenya. I know there's more people than just Kenyans here, but if y'all will just say, hey, Thom, I was in the Data Science Toolkit in Kenya thing, that will cue me to, okay, yeah, make sure I send this person that initial message, and then also send me your Gmail address so I can invite you. That is if you want, to our integrated machine learning family, and also to our Saturday morning mentoring sessions. You'll be on the invite list. You know, just come when you can, come late, leave early, it's fine. Just come when you want, when you get those invites. Okay, no new questions. Someone has raised a hand. Go on ahead. That was from, if your question was answered, go on ahead and lower your hand so it won't be confusing on my screen. Apart from Python or R, which other tools are important in data science? Oh, well, for sure, SQL. Oh, I'll put that in there. Oh, in fact, you're probably asking for the Slack channel. So SQL, let me talk about the tools, then I'll go to the name of the community. Now, there's another language popping up on the scene called Julia, but frankly, I would put that on your learning plan, but don't look at it until you feel like you're really good at Python or R. But I think Julia is a language to watch. And I'm a big fan of the book called The Pragmatic Programmer. That book has really good coding advice. Even though we're not software developers, we kind of are, and with just our work's a bit different. Okay, other than SQL, if you are having trouble breaking in don't worry about your first role being data science. Just get as close to data science as you can and build that experience. And so in that spirit, if you know Google Data Studio or Tableau or Power BI, those are rapid visualization tools. And sometimes you can get an introductory data practitioner job with those because you're good at those tools. But you can also still do great visualizations with Python or R and the modules that come with those. But sometimes you can just go faster with Power BI or Tableau or Google Data Studio. And the good thing about Google Data Studio is it's free. And I think I'm saying the name right. In our Slack channel is called, I'm going to put it here in our chat, Integrated MLAI. So yeah, you can send a connection request right to that. That would be fine too. I just usually add people. Okay. Oh, good. Thank you, David. I'm glad. And David, that was such a good question. I think too, as you're online, as you're continuing to grow, be part of the community, that learning plan, I suggest having it in a workbook format. I'm a big fan of Google Drive and using Google Sheets. So I would have a Google Sheets workbook, and I have a learning plan in there, but sometimes there's things I want to add to that learning plan, and you can have a separate worksheet that's just called tools. And so your tools are Python, R, SQL. Now you can add Power BI, Tableau, Google Data Studio, but you might put those on the same line. Just say rapid visualization tools, rapid storytelling tools, and put those options on the same line. But just by getting good at SQL and Python and many of the modules or libraries in Python or R, you're going to be moving the right direction. Anyone else? I'm eager to get to accepting your connection request, but I'm trying to focus on our time here now. One thing I want to encourage you guys about is, as you're growing, always look for ways to be more efficient. Don't be an efficiency junkie where you can't stand to do anything until you make it more efficient, but always look for ways to do everything you do more efficiently. And that's one of the great things about Python and R. The reason I like Python over R is because Python can do almost everything. And so, you know, I try to automate as much as I can with Python. And, but then it's not just that. I'm on LinkedIn a lot. I don't want to be on it too much. So I'm constantly trying to find faster ways to get my work done in LinkedIn and get back to my studying and learning and development that I do for my job and for integrated machine learning and AI. Any more questions? I hope this is being helpful, and I'm really eager to get that message out to you guys because it covers far more than I could discuss in our short session here. But it has links to rock solid free textbooks. It has links to some talks I've given on other things I would want to share with you that I think would help you in your career. It has links to blog posts that I've tried to write carefully on my own or with others' help to help the community. Just really, oh, thank you. Thank you. Okay. Mwangi, and please, I want to say your names better. I'm pretty decent with African names. Oh, by the way, just so you guys know, my wife and I adopted 3 kids from Liberia. So I do feel like I'm part African, not in skin color. I know there's white people, and I know there's many skin colors in Africa, but seriously, I as far as Central Africa or the west coast of Africa, yeah, we love our African kids. Yeah, thank you, Adams, and I'm glad the session was really helpful. Good, good. Thank you, Monkey. Oh, good. I'm glad, Cyrus. Good, good. Thanks, Stephen. Yeah, it's funny. I went to pick them up in 2006, and one of them's already moved out of the home already. So, hoping she'll do well. Okay. Any other questions? All right. Good. Yes. I am trying to do my best, and I'm not always a perfect father. I'll tell you all that. I'm glad you liked it, Vincent. Good, good, good. And by the way, we can do future sessions. I would love to, if y'all want to do another session in the future, I can bring some of my teammates with me. I would love to do that. Oh, good, Alan, thanks. Asante is our Kenyan word for thank you. Oh, thank you. Okay, I'll try to remember that one. That's good. Well, I hope you'll follow my posts on LinkedIn. There's one post I want to just paste in here in the chat, one of my blog posts. And by the way, I'm very happy when I get a chance to do one of my, I like to call them math to complete code without Python or without NumPy or SciPy. I love to do those kind of posts because they get down into the nitty gritty details of the math. And I love to do those kind of posts, but I just found that there were greater needs in the community I'm trying to serve. But that post on being a data scientist, that's one of the posts that I would have linked when I send you that big message. And then another one that's a lot of people seem to really appreciate, put it in here. Again, these are part of that big message, but if you guys wanted to copy those to look at them later, that would be great. And I'm glad you guys found the session valuable. Just trying to do my best here. I know we're all at different points on our journey, and I just want to be as helpful as I can. And I'll still stick around. I know some of you need to drop off. We had a good show up, and I know people have other things to do, but I will hang around till the end of the scheduled time for y'all. How is your internet in Kenya? Is it pretty good, guys? I get the sense most of you are operating on cell phones for this session. Is that correct? I could be wrong. I'm trying to get a a more accurate feel for the resources there. Okay, understood. Depends on the ISP, location, but the internet is fast. That's good to know. My wife got frustrated with all the cables my kids and I had running through the house along the floor. And okay, good, Adams, good to know about the cell phones. But she got so frustrated with it that she did her own research and bought and installed her own wireless for our house. And I prefer cable, but this wireless that I'm on is so good that I don't miss a beat with it, so it's fine. Are some of you in college programs, or are you learning data science on your own? What's the educational structure like there for you guys? Those of you in university, do you like your university programs pretty well? Okay, that's fine. I don't see any answers to that, but I'm just trying to understand. Oh, excellent. Do you like that, Cyrus? And then Stephen, you said yes, but I think you meant yes, you're in, I want to make sure I'm clear. Yes, you're in what? Okay, thank you. At most, we do it on our own. Okay. Boot camp and self-taught, taking a different course, but studying data science on my own. Excellent. Okay. Okay, great. We're trying to get that course done ASAP, but it's going to take some time because we're really intending to do it right. And one thing we're eager to do is the textbook's always going to be bilingual, be first English and Arabic. then English and Hindi. And I don't know what other languages you guys speak in Kenya, but would that be helpful if it was English, and what other language would you guys want it in? English and English. Okay, good. Okay, good. Swahili. Excellent. Yeah, that's what I would have guessed, but I wasn't sure how extensively Swahili is taught or used in Africa, but that would be good. And so just English. Would it, does it help to have the Swahili next to the English, or your English, you just don't need the Swahili in your opinion at all? It'd be good to know, because there may be a version we make that's just all English, and we're trying to get a feel for, other than the states, if that would be important. Well, okay. Most of us don't even speak fluent Swahili. Okay, good to know, Mongi. Okay, good to know, good to know. That will challenge us to think of, yes, that's true about English is the most used language in academia. That's a fact. However, we find that sometimes there's a barrier to collaboration with certain cultures because their English isn't necessarily as strong as your English, or they really still prefer, say, Spanish. You know, having a Spanish side next to the English would really help them. That's good to know about you guys in Kenya and nearby. And let's see, Kenya is not super close to Nigeria, of course. That's quite a distance, actually. And then there was the Tanzanian, so that is close to Kenya. Yeah, good, good. Do you guys like data science boot camp, and who is that through? Because I think there's multiple ones called, is it DeFi by chance? What group is that with? Oh, so many of you were saying you were learning from Data Science Boot Camp. And I was wondering which group is sponsoring that course, or which group produced that course? Well, that's okay if y'all don't know. Data Science East Africa. Okay, so, okay. I probably should get to know that group. That's good to hear. Do you guys do any of you use free Udemy courses or Udemy courses? Okay, good. Yeah, that's good to know. All of you will want to follow the best free resources come from, in my opinion, a handful of people. I'm getting their connections for you. Yeah, there we go. Okay, this is a good friend of mine that I'm putting in our chat. He is really good about sharing free resources. He's like a son to me. And then there's Robert. I hope all of you are connected with him. But here's his handle, in case not. And then also Arpit Singh. Really like this guy. And if you follow them on LinkedIn, they're frequently sharing free resources. So I hope that helps. Oh, good. Coursera too. Great. Yeah, many of those materials that in other words, if you follow Danny and Robert and Arpit, the resources they're selling or sharing, are usually free. And yeah, I think Coursera does have some free courses. By the way, MIT's data science program is online for free now, I understand. And some of the lectures I've watched out at MIT, I think they're really good. And I want to encourage y'all, when you hear something in a course you don't understand, pause that course and treat that as the next little thing you've got to go learn. Okay, great learning academy. Good to hear, Alan. Thank you. So guys, if you don't mind, and please let me know if you need me to stick around a little longer, but my voice is getting really dry and I think I need to go drink and eat, but I can hold on for another 9 minutes if y'all want me to, but I sense we're kind of tapering off. Were there any last questions before we say goodbye to one another?
Can you share your contacts?
Say that again, Stephen. I missed that.
Okay, can you share your contacts with us?
Oh, so literally, I kid you not, if you connect with me on LinkedIn and message me there, that's the best way to communicate with me. And then if we need to have a call, I send a Google Meet link that I use over and over for when people need to have calls. But what most people are finding, if they contact me on LinkedIn or they join our Slack channel and message me there, and they come to our Saturday morning, my Saturday morning, your Saturday afternoon mentoring sessions, they get a lot of help that way. But when you need super specific help, we just kind of deal with that on a case-by-case basis. So, by the way, I'm saving y'all trouble. I don't ever answer my cell phone because it's 95% scam calls. And so anyone that needs to contact me knows to contact me by those ways. So link to my Slack channel, yes. I guess I need to set that up better. What I've been doing is just having people message me with connection requests on LinkedIn, giving me their Gmail, and then I just add their Gmail in. But it's here. See, I think I can copy it. Yes, I'll just put it in here. I think you can send me a connection request to it. And here it is in the chat window. Does that help? By the way, even my closest friends know, oh, don't call Thom, text him first and then say, can we have a call? That is if we need to. And it's to save you guys time too, because it just, trust me, it works better. I do want to help everyone as much as I can. So far, I'm still able to get all my work done and help a lot of people. So that's why we do the Saturday thing, and why we do the Slack channel. And plus you get better help because you get help from more than just me. That's what's important. So yeah, I'll watch for connection requests, but if you're having trouble connecting to our Slack channel for some reason, just let me know, and just send me your Gmail or email address inside a LinkedIn message and I'll get you added. But yeah, try to do that a lot. Oh, Cyrus, you're welcome. It was an honor to be with you guys, and I hope you'll count me as your friend moving forward. I want you to know, a lot of people look up to me. To me, I look up to you. Guys, you're the future of data science. it's my humble honor to give to you because you're the future and you're going to do greater things than my generation is doing now. So trust me, the honor is mine. It is. And so I'm really serious. If I don't answer your message on LinkedIn, it was only because it got lost. And all you need to do is say, Thom, same question. It'll rise to the top of the stack. But I try to answer every message on LinkedIn. I really do. Oh, yeah, I'll share my LinkedIn. Basically, if you just search on Thom Ives, PhD, but let me give it to you again in here. Oh, I've got it in another window. Keep handy. There we go. Getting that right now for you. Oh, it's in another window. There we go. In fact, I'm going to share some others with y'all. There's a bunch of links. So the top link is my LinkedIn. Then there's my GitHub repo. And then the integrated blog website again. And the final one is if you wanted to just go read my posts, that link will take you directly to my posts, not my activity, but just the things that I post, if you wanted to look through those. And yeah. Candy, you would want to ask one of the organizers of this for that question. I hope someone will take Candy Wendy's question. She's saying, sorry, I got to hear about the meeting a bit late, so I missed the session. When will the next meeting be? Well, guys, I'm glad you appreciated this time. I sure did. And I look forward to interacting with y'all. Oh, Adam? Okay, good. Any last final questions? All right, guys. Going ahead, Mandela. Oh, yes,
Thank
Robert
you.
Jane. Robert Jane? Is Robert Jane on here? Is that correct? Robert, are you on here? Oh, Robert, wow. Hey. Oh, good. I'm glad, Adon. Robert, what's your question, buddy? Robert's like my son, guys. Oh, thank you, Robert. So are you, buddy. Y'all really need to be following Robert because he shares a lot of free resources and he works for a publisher. So he knows what books are good. And you're welcome, Adon. Again, it was an honor to be here. It really was. All right, guys. It's always hard for me to say goodbye on one of these. I'll just say one of my favorite things to say to my team that I'm very close to is pause. That's our easy way to say it's not bye. It's just we got to go do other things now. But God bless you all. I'm glad it helped, and I'm just praying for you on your journey, guys. Take care. Mandela, thanks again for organizing this. Yes, go ahead.
Thank you, Thom, for the session, and I'm also grateful for you for giving us your time and sharing the knowledge that you have. Yeah, I'm really grateful. On Candy's question, okay, the meeting has been recorded, so you'll get a recording of the meeting. And also, we'll also have another session next week on Friday. More information will be communicated to you on the WhatsApp group and the Slack and the Twitter handle. Yeah, that's all. Thank you. Oh yeah, before you guys go, can you guys turn on your camera? I take a Snapchat, a screenshot of all of you who attended the session.
Excellent. And yeah, guys, and I guess if I hang up, it won't end the meeting. So I do need to go, but it's really a blessing to be with all of you. God bless you. Hope to talk again. Take care.
Okay, so can you guys open your cameras? Thank you. Thank you. Okay, we are left with Sharon, electrical engineer, and Steven. Okay, so I'll be taking the picture in 3, 2, 1, go. Yeah, done. Thank you. So if you're not in the Slack group or the Twitter or the WhatsApp group, kindly, inbox me. Thank you.